This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 5, Lesson 2, Piping and Hydraulic and Pneumatic Components. Lesson 1 held pressure in a vessel wall. Now, we let that pressure move. A pipe is the same thin wall vessel, rated by the Barlow formula. And a hydraulic cylinder is a pressure vessel that does work. Pressure on a piston becomes force. We'll rate a pipe, then build the extend and retract forces, and see why a cylinder pushes harder than it pulls. Concept 1. Piping. A pipe is just the thin wall vessel from Lesson 1, drawn out long. Its maximum working pressure comes from the Barlow formula, and the hoop stress still governs at twice the longitudinal. Thicker wall or smaller bore raises the rating, a bigger diameter lowers it. We'll use Barlow to rate the line that feeds the cylinder. Concept 2. The cylinder. Cap a cylinder, drop in a piston and rod, and the contained pressure does work. Force is pressure times piston area. Extend pushes on the full bore. Retract pushes only on the ring left after the rod steals its area. So at the same pressure, a double-acting cylinder pushes harder than it pulls. Concept 3. The equations. Extend force is pressure times the full bore area. Retract force is pressure times the annulus, the bore minus the rod. Each inverts to solve for the pressure a target force needs. The rod term is the whole story. It removes area, so the pull is always weaker than the push at equal pressure. Concept 4. The rest of the circuit. Around the cylinder sit the valves. A directional valve routes fluid to one side or the other. A relief valve caps the pressure, a check valve holds a load, and a flow control valve sets the speed. The handbook prints the cylinder forces, not valve sizing, so know what each one does. Commit the functions to memory. Setup. A double-acting cylinder, 3-inch bore, 1.5-inch rod, supplied at 2,000 psi either way. Then, a separate 6-inch pipe to rate by Barlow. The plan: areas first, then the extend and retract forces, then the pipe's pressure rating. Solve. Part 1. Bore area times pressure puts the extend force around 14,140. The annulus, bore minus rod, gives a retract force near 10,600. The rod steals about 3,500 of push, so the pull is 3/4 of the push. Solve. Part 2. Barlow rates the pipe at 1,250 psi. That's below the cylinder's 2,000 psi supply, so this wall is too thin for that line. You'd need a thicker wall or a smaller bore. Same thin wall membrane as the vessel in Lesson 1, and it uses the diameter. Traps. 5 ways this bites. 1. Retract uses bore squared minus rod squared. Never the full bore. 2. Pick the area for the stroke. Bore to extend, annulus to retract, and their separate load cases. 3. Barlow takes the diameter, not a radius. 4. Keep everything in inches. PSI on square inches gives pounds. 5. The force equations are the cylinder sections. The pump curves that follow are a different topic. Quick recall. Rate the feed pipe by Barlow on its diameter. Drive the cylinder on the right area. The full bore to extend. The rod side annulus to retract, and each force equation inverts to give the pressure a target force needs. Golden rule: pick the area for the stroke, and the rod always costs you push on the way back. Next up, Lesson 3, Springs, Part 1, Helical Compression. The vessel held pressure, and the cylinder spent it as force. A spring stores it. We'll build the spring rate, the shear stress in the coiled wire with its correction factor, and the energy the spring holds. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.